All right, for the next section, we're really going to focus on parallel lines. Back to that yellow graphic organizer. You need to know all the types of angle pairs that can be formed with parallel lines. So really, and then how to prove. So if you know the lines are parallel, then the following could happen. All right, let's do it this way. Let me undo this. If I know parallel, then they can either be congruent or they can be supplementary, which is 180. The ones that are congruent are alternate interior, alternate exterior, and corresponding. The ones that are supplementary or 180 are same side interior or same side exterior. Same side interior is the same thing as I do consecutive interior. These are the same. And this is the same as consecutive. I'm just abbreviating, guys. Exterior. All right, so the first thing was just make sure you can understand what alternate interior, like, can you find the type? Okay, so this is just knowing your vocabulary, identifying, matching the type on the diagram. So on here on A, they want us to focus on angle 1 and angle 3. If I angle 1 and 3, that means the transversal they share is this line. They're both above the line, kind of in the same position. So this would be corresponding. So this one is 4. If I'm looking at 3 and 13, no, sorry, 2, which is over here, and 13. Now they have a different transversal. They have this line. These are alternate exterior, so that is 2. 8, which is over here, and 11. These would be alternate interior. That's 1. Because they're on opposite sides of the transversal. All right, then if I'm looking at 6 and 7, they're both underneath the transversal is this yellow line, but they're in between the other two lines. These are same side interior or consecutive interior. So that's 3. And then we're looking at 12 and 15. 12 and 15 are straight across from each other. That's vertical. That's 6. You still got to know those. And then 9 and 10. 9 and 10 are on this line right there. They're adjacent. They are the linear pair. So that is 5. Okay, so just know the types. You got to know those types. Look at your spiral. Now we're using those. Now we're using this up here. So I probably should have did this. So yeah, oops, sorry, done. So I'm just gonna copy this. If it lets me, hold on just a second. Okay, so I just kind of brought this relationship down here so you can see it. So I'm using this on this section. Now on 41, they're telling me that both sets of lines, so L and M and A and B are parallel. So which angles are congruent to the 42? Well, everything, the pattern is going to hold. Whatever happens here is going to happen down. So what's on A would happen on B. What's on A and L here is going to go to M. So that pattern is going to continue. So you just need the angle numbers. This should be 5, 8, 13, 2, 7, 10, and 15. The supplements, those are what make up the 180. So this would be here, like the 138. Okay. The 138s are actually angle 1, 4, everything else, 9, 12, 13, not 13, 3, 6. Oops, what happened? Sorry. There it is. 3, 6, 11, and 14. Okay, so we can remember which ones are congruent, which one are 180. That lessens our work. So to be a supplement, it has to be one of these two types. same side interior, or same side exterior. So if I'm looking at angle 6, all right, in comparison to my L and M, I need a same side interior. So we should have B here. 6 and 10 are on the right side in between L and M. If I'm looking at angle 11 for an angle 11, if this is 27 and I'm trying to get to angle 8, well, angle 8 and 11 are alternate interior. And since they're alternate interior, they're going to be congruent. So the answer is D, 27. And then angle 6 and 9, if I look at 6 and 9, these are alternate interior. And alternate interior angles are congruent. So since they are congruent, because they told us they're congruent, then our lines L, like that, a cursive L, is parallel to M. So this one was A. All right, and then we're going to kind of solve algebraically. Okay. So they want us to use the fact that the lines are parallel to find the measure of the angle. Well, I'm focusing angle 1 and angle 3. Angle 1 and 3, well, they don't have any special relationship, but if I make this vertical, okay, one could have the same measure here. And what if when I do that, I have same side interior. So you have to use same side interior, angle 1 plus angle 3, being supplementary. Same side interior equals, or supplementary, they equal 180. And then you can set up and find your measure of angle 1. Okay. Find your x first, and then plug it back in. Okay. Your measure of angle 1 equals to be 52. On this figure, we have two sets of parallel lines, the L and the M, so that's the horizontal, and the AB and the CD. They also tell us that CD bisects AC. So here's C to D is bisecting this angle ACE. So that means 10 and 9 are the same measure because it's getting, the whole angle is getting cut in half. And we know that the measure of angle 1 is 130. Well, I can do linear pairs, so that's 50. I can do same side interior or alternate interior, that's 50. I can do vertical, that's 50. Okay. To get into my 9 and 10, I'm using the parallel lines of two sets and using corresponding angles. So because I know this angle here is 9 and 10 together, this angle corresponds to angle 1. So that means this whole thing is 130, but I'm going to cut it in half, which means each angle would be, 65. And now I can use my triangle to get to my angle 4. And then I can use vertical angles. I can use some more triangles. So angle 3 we should know already because we use the same side interior. That was 50. Angle 11, well, it is going to be corresponding to angle 2. So that is also 50. Angle 13, which is over here, it is the same side interior. So if I know that this was angle 50, this would be 130. And then angle 9, which was, let me get a different color. Angle 9 was right here. And we see that that was that 130 cut in half, which was 65. All right, that takes care of part 3. Now we're just back to triangles for part 4.